Gee, yeah, continue from first video. So this is the data, empty car, and I am loading it in for further analysis. If you want to see the first 5 or 10 records from this data set, you can write this and press Control Enter. So you can see this is the data set with 5 or 10 up to 10. So it's showing 6 rows and there are total 11 columns, 11 variables. You can see the data here as well on the right side. It is under the environment. So then you can see the dimension. Dimension of this matrix, the data is 32 rows, 32 cars, and 11 variables. You can also check for the number of rows, n row or n column, but dimension is giving you both things, n row and n columns. You can also print a summary. So this is the summary for all these variables. There are more packages that you can see that will provide you more and more information. You can explore them by yourself. So if you want to print only one outcome or further outcomes, you can use a print statement outside your command. So it is simply print and what you want to do. So just write inside the parenthesis. So, but you know that R, just like other languages, R also depends on a number of packages. For example, if you want to upload a CSV file or Excel file, normally CSV don't need anything, any library, but for loading a Excel file, you need a library. So read Excel. If I control enter, if it works okay, then there will be no error. If it is giving you any error, so you can write install.packages and read Excel. So if you are using this for the first time, you should put this line before the library. So first you call the install packages and then you call the read library read Excel. The other way around is to do the install packages and go to install. Here you have read, and you see you can have a read of different types. Then I just say XL. So XL. So there are still two types of packages, but I need a very simple one. I'd say read Excel, and it's showing because you already have installed it. Why you're doing it again? As I do it. So it is showing install packages and whatever the specification about this. So it's done. Once it is done, then I run the library packages, library of the read Excel. Similarly, for example, library, and I need one more package, for example, ggplot2. Let's say this done. And if I cannot do it from here, I can go to this, I write a ggplot2, and it's for movies or ggplot. So there are so many different ggplot.gui, ggplot.ify, and so on. I need just two, simplest one, and install. So because it's already installed, it's asking me why you are doing it again, and that's done. So there are more than 20,000 packages in R. You can see what packages you require for basic statistics. This is simple stats module. So you just need to see which module you can, which packages you can use in your analysis. If you want to run the whole block of this whole block, that is called chunk of this code, you can you can click on Control Shift and Enter. With the Control Shift Enter, you can run the whole block in a single run. Yeah, so if you want to load some data, for example, my data is equal to read CSV file or Fortran file or read underscore Excel or read XLS file. So there is so many different type of readable files, DBMS, RDBMS, so whatever. So for example, I say CSV, and then I need to give the file path here .csv, file name .csv. So you see, notice it is a backslash, it's not a forward slash. And you can write get wt, get working directory to see what's the working directory, and you can do the set wt, and in the set wt, if you put it here, give the folder path here, and then if you write this way, oh sorry, it's wrong. So then you don't have to define the full path in the read csv file. You can just do this step. So this is a way, if you are using some CSV file which is downloaded from internet or from your data source, then you can use the read CSV or read.csv or read underscore Excel or some command. You see read, sorry, read, and then you have a large collection of commands that you can use to load a data set into R. So they are very simple, just maybe 5-10 minutes of exercise and you can get onto it. So I will be using empty cars data for this exercise. RS data set is also one of the famous data sets, but we will not continue with RS data. We will continue with empty cars that I have shown you. It has a large 32 observations. Miles per gallon is an important variable. Number of gears in the car is important, and number of cylinder is important. So we will using these. Weight of the car is important. So we will use these information for different statistical testing. Okay, one more thing. Sometimes we have to convert a categorical data, for example, gender, male, female, but some analysis don't accept categories, English letters. You have to convert them into 10 or 01. So we can say that we can use the command. This is a command, for example, this is called as.numeric. For example, if I show you iris data, in the iris data, there is one column that is called species. There are 3 type of plant flower species. And then if I say this is a $sign to call a particular column, a species, and I say as numeric, I want to convert these English names into numbers. So I say as numeric. So when I did it, you see this is showing 1, 2, 3, Setosa, Virginica, versicular, and Virginica. So these are the names of these. We can see them. Table, iris, and species. We can see them. Setosa, versicular, Virginica, 50, 50, 50 for all these 3. So we can make the table to summarize data. For example, I can see a table because I am using empty cars, and I say number of gear. So you see 3 gear, 15 cars, 4 gear, 12 cars, 5 gears, 5 cars. And we can change it and we can see some other thing, number of cylinders, 4 cylinders, 6 cylinders, 8 cylinders. So you see we can do the table with 2 variables, empty cars, if I am not wrong, so it is okay, and gear, yeah. So see, cylinders are 4, 6, 8, and gear are 3, 4, 5. 4 cylinder, 3 gears, 1 car. 4 cylinder, 4 gear, 8 cars. So you see this is a table between 2 variables. So we can have 2 variables or 3 variables or 4 variables using the table command. You can summarize your data using this command as well if you like, if it is required. In the next block, which is the number 3, basic plots. In the data visualization, there is a large number of different plots that you can make, but if it's up to you how much you want to add. We can do a scatter plot where we have X and Y variables. We can do histograms, we can do box plots, and so on, as much you like. It's up to you. So this file is a basic skeleton about the coding and how to write the report, and then as much as you like, you can do additions. This command is showing I am attaching this file, attachment means if I attach this file, that means I don't have to write like this, empty cars $mpg. If I attach it, then I can say in place of this, just use mpg, and this is a comment. So that's simple. So if you are using only one file in your analysis, in your practical, so you can just use the empty cards and you can ignore this dollar sign. Dollar sign is used to call a particular column name, particular column in the data. So you know box plot from first semester, we can make box plots. For example, I made a box plot for the miles per gallon where I am using different VS and different, for example, gear. Sorry, empty cars here as well. Gear, figure 1, miles of 4 types of gears, and rainbow, 3 colors of rainbow. So if I click on it, it will show me the plot, and it is showing me 3 gear, 4 gear, or 5 gear, and there are different colors. So you can make different plots for the miles per gallon or horsepower and so on. So up to you how much analysis you have to do, and you have to check x-axis, y-axis as well. The advanced one is ggplot2. It's a very large library, very famous library in R, and still it is useful. But to be up to a certain level, I am not going to include it. There are already built-in packages and available websites that can help you just straightforward to make histogram or box plot or scatter plot from ggplot2. But ggplot2 is a commercial thing. Histograms, for example, my empty cars is the data, miles per gallon. I want 15 columns, so no, 15 bars in the histogram. Color is gray, and X label and main. So if I click it, I can see this histogram with 15 bars, continuous bars, and x-axis and y-axis and title. So you can make as many histograms as you like that fits your requirements and the variables or columns that you will be using for hypothesis testing and other analysis. So this is something about the histogram and box plot and simple plot. You can do plot between empty, so mpg comma horsepower. Horsepower is not found. Yeah, that's a problem. Where is, yeah, type empty cars. So I am just taking it fully. If I did it, so I can see the scatter plot as well. You can beautify it. You can use colors. You can use small and large circles. So up to you. And so this is a basic skeleton, so it will not have much more. If I do it blue, that's blue. So it's not magic. It's simply one line or changing options, and you can play as much as you can, and you want to. Next block is about the correlation. We can do the correlation metrics, correlation between each pair of variables using the COR command. So if I click it, it is showing me the correlations of each variable with the other variable. For example, miles per gallon correlation with number of cylinders minus 85%. That means higher the number of cylinders, lower the miles per gallon. It is very strong negative correlation between them. And see, there is a very strong negative correlation with more weight, DRAFT drift, maybe something, horsepower, DI displacement, not displacement. All of them are negative relations with miles per gallon, but Q-sec and VS and AM and number of gears, they have more number of gears, more miles per gallon, and CARB. So there are most of them are negative, some of them are positive, but it is not easy to see all of these in a single go or understand it, that means we should use some plot. So there is a library that is called correlation plot library. Control enter, it will install it. If you fail to install from here, you can use here core plot, COR plot. So you can do it from here and install, because it's already installed in my computer, so I will repeat it. So core and your data, which data frame you want to work with. My data is empty cars, so I did the correlation matrix and stored it into core.met.empty cars. .met dot is not mean to say it's a property, it's not like Visual Basic, so it's just name that you, there's a variable name still. Correlation core plot, when I make it, you can see a beautiful simple map. It is showing blue, dark blue are positive correlation, dark brown or reddish type are negative correlations. You can make this very easily, and you can come into which variables are related with miles per gallon or horsepower, or number of gears. So it is very easy to interpret comparative to the metrics of numbers, comparative to comparative to this. Look, if I do Control Shift Enter, it is running the comparative to this whole matrix. It is very easy to interpret and analyze, write analysis based on this diagram. So next video will be about confidence interval and hypothesis testing.